Schrödinger's cat has inspired a lot of jokes. My t-shirt here has a picture of Schrödinger's emoticon. It's happy and sad at the same time. Now, all these came from a very serious paper that Schrödinger wrote in 1935. It was called The Present Status of Quantum Mechanics. He had a lot to say about the good points and the not so good points of quantum mechanics at that time. Everybody remembers that one paragraph about the cat. Now, the same year, Einstein wrote a paper called Can Quantum Mechanical Description of Physical Reality Be Considered Complete? Both Schrödinger and Einstein said quantum mechanics is certainly correct as far as it goes because it gives us the right answer to all the experiments that have been used to test it. And now, almost 100 years later, that's still true. Quantum mechanics gives us the right answers. But both Schrödinger and Einstein said there must be something more to it because it gives us a lot of probabilities when we expect definite answers. Now, for example, suppose I drop this ball and I wanted to know when it's going to hit the floor. Classical mechanics will tell us something like half a second. That's a definite, concrete answer. No probabilities of this or that. And Schrödinger, that was the main point of Schrödinger's paper, that you just get probabilities, and so he kind of emphasized that with the probability of the cat being dead or alive. He said, we don't expect that from a physics theory. Now, in the story of the cat, it's the cat itself that gets the most attention for a lot of good reasons. But I want to focus on the radioactive material that had that 50% chance of decaying within 1 hour. Now, Schrödinger was most likely thinking of some naturally occurring radioactive materials like uranium, where we could measure out a few grams of uranium and get that 50% probability. And he picked 1 hour just as a convenient time to run the experiment. Well, today we can make short-lived radioisotopes that, in principle, we could have just used 1 atom to run the cat experiment. Okay, there are several different radioisotopes that are used for medical purposes, and they have half-lives of around, say, around an hour. One of them is carbon-11. The half-life is approximately 20 minutes, so let's just pretend it's exactly 20 minutes and that one of these balls is a carbon-11 atom. Suppose we take a whole bunch of carbon-11s out of our nuclear reactor and put them in separate compartments so that we can number them. Okay, and then let's say the first 5 atoms, the first 5 numbers where the atoms decay, those are the winning lottery numbers. That's what I call Schrödinger's lottery. And those would certainly be random. Because what quantum mechanics tells us is that if you take a carbon-11 fresh out of the reactor, then it has a 50% probability of decaying within the first 20 minutes. Also, at any time later, as long as that atom is not decayed, you still have a 50% probability of decaying in the next 20 minutes. Now, for a conventional lottery, what we do is take a bunch of balls and put numbers on them, and put them in a cage and tumble them around until we don't know what's where, and then we take off the first 5 balls, and those give us what are random numbers for all practical purposes. But according to classical mechanics, if we knew exactly how those balls were placed in the container originally, and if we knew exactly what the mechanism was for tumbling them around, and if we had a big enough computer, then in principle, we could predict exactly which are the winning numbers. Quantum mechanics is different. It tells us that the time for the decay of a radioactive isotope is fundamentally random. There's no way in the entire universe that we could ever calculate exactly what it is. Both Schrödinger and Einstein said, well, that means the theory is missing something. So, is quantum mechanics the final word? Well, today, again, almost 100 years after Schrödinger wrote his paper about the cat, people who work in quantum gravity are still trying to figure that out. Some of them say, yes, quantum mechanics is rock solid. That's the final word. So we just have to modify the theory of gravity to make it fit. Other people think, no, we probably need to upgrade quantum mechanics also, but they don't know how to do it. So even though we don't know whether Schrödinger's cat is alive or dead, the story of Schrödinger's cat is still very much alive and well. Thank you for watching.